Hello. I will briefly present the work titled Group Fairness in Recommendation Systems, the importance of hierarchical clustering in identifying latent groups in MovieLens. Recommendation systems act as filters for users amid the vast amount of information available on the internet today. However, one of the issues associated with these systems is group unfairness, which occurs when one group of users receives different quality recommendations compared to another group. In this example, the female group is receiving worse recommendations than the male group. Our main contributions were analyzing group unfairness with a type of clustering that considers correlations between various user characteristics, considering model-based and memory-based strategies in this analysis, and implementing group unfairness based on the variance of group losses. The overview of this work's methodology begins with the calculation of recommendations using traditional recommendation strategies. The estimated matrices, resulting from these strategies, are inputs for the module implementing the group fairness calculation. Users were grouped into 4 different clusters, by gender, age, activity level, and, with a highlight on the hierarchical agglomerative method, which seeks to identify latent groups. Group unfairness was measured in each configuration combination. The experimental settings were use of the MovieLens dataset, after filtering 300 users and the 1,000 movies with the highest number of ratings. The recommendation algorithms tested were ALS, NMF, and KNN. The first 2 are model-based, and the latter is memory-based. It is important to highlight the number of users in each group within these clusters. Among the main results, we have the group unfairness values for each of the clusters, calculated from the recommendation matrices generated by each of the recommendation algorithms. A subplot for each of the recommendation algorithms, and within each subplot, a bar for each of the clusters. Highlighting the agglomerative clustering, which, on average, exhibited the highest group unfairness indices. This underscores the existence of latent groups, as well as the need for a deeper study to understand complex patterns and possible correlations between user characteristics. Another important point was the greater sensitivity of the KNN algorithm to the number of groups within the clusters. This method exhibited low unfairness for clusters with few groups, e.g., by gender, and high unfairness for clusters with a larger number of groups, e.g., by age. Losses for the groups within the clusters were also calculated. In this figure, each bar represents a specific group within a cluster. For example, in the gender clustering, the groups are male and female. In this context, the main conclusions were that the female and inactive groups experienced the highest group losses within their respective clusters, regardless of the recommendation method. Also noteworthy is the agglomerative clustering in the KNN method, which showed higher group fairness but lower accuracy. This indicates that the most accurate method is not necessarily the fairest. All implementations of the fairness metrics and the scripts for the analyses across all configurations of methods and clusters are available in the following GitHub repository. We highlight 2 of the main conclusions of the study. The first is about the importance of balancing accuracy and fairness in recommendations. The second is about the unfairness present in latent groups identified through techniques such as hierarchical agglomerative clustering. Thank you very much for watching.